Hello guys, in the previous lecture we discussed about Cauchy's integral formula and how to derive it, and also about the general form of the Cauchy's integral formula. So in this lecture I'm going to discuss briefly about the examples related to the Cauchy's integral formula and the general form of the Cauchy's integral formula. So now we will see one by one. The first one is evaluate integration over the region C e power z by z plus I pi dz over each of the following counters C. So we see is defined like this. The first counter is modulus of z is equal to 2 pi. The second counter is modulus of z is equal to pi by 2. The third counter is modulus of z minus 1 is equal to 1. So here these curves represent that. So here the first curve is mod z of 2 pi is nothing but a circle with center at 0 and the radius 2 pi. The curve number C represents that a circle at center at 0 and radius pi by 2. The third curve mod of z minus 1 is equal to 1 represent that a circle with center at 1 comma 0 and radius 1. So the first thing is we have to compare the given equation with the Cauchy's integral formula. So we can see here the function z minus a is of order 1. So directly we can use the Cauchy's integral formula. So if this is z minus a form means the given equation is z plus I pi is there. So I can take a is equal to minus I pi here. So we'll see how to solve the equation one by one now. So from the Cauchy integral formula, we have the equation like this. Integration over the region C, f of z by z minus a dz is equal to 2 pi I f of a. So here the given equation is like this actually. Integration over the region C, e power z by z minus of minus I pi dz. So on comparing this equation with this equation, we can take a is equal to minus I pi. So according to the formula, we have to find only f of a. So from the given equation, we have to identify what is f of z and we have to find the value of f of a, that's it. So here we can compare this one and this one. So it is clear that f of z is nothing but e power z. So f of z is e power z and a is equal to I pi. The points will be like this now, 0 comma minus pi. Since here I pi is there, so this point will be lies in the negative this point will be lies in the negative y-axis. Since a is equal to minus I pi we are having, so the point will lies in the negative y-axis like this. So point will be 0 comma minus 5. So x is equal to 0, y is equal to minus pi will be the point. The first curve is the given like modulus of z is equal to 2 pi is a circle with center at 0 comma 0 and radius 2 pi. So now I should draw the circle of radius 2 pi with center at 0 comma 0 and I should find out where the point lies in the circle mod z is equal to 2 pi. So I'm going to draw the circle like this. So after drawing the circle with radius 2 pi, so the point 0 comma minus pi will exist here. So we can conclude that the point lies inside the circle. So if the point lies inside the circle, the formula will be exist. Say if the same way, if the point lies outside the circle, here or here or here, so we can take the formula will be 0. So since here the point lies inside the circle, I can find out the equation now. So since in the function I am replacing a is equal to minus I pi. So 2 pi I into, since the function f of z is e power z, I can replace the value of a here. So I will get e power minus I pi. So the formula for e power minus I pi is cos pi minus I sin pi. Sin pi is 0 and cos pi is minus 1. The solution will be minus 2 pi I. So the integration over the region C, e power z by z plus I pi dz is minus 2 pi I for the curve mod z is equal to 2 pi. The next curve is mod z is equal to pi by 2. Is a circle with center at origin and radius pi by 2. So here also I am using the same points only. The point 0 comma minus pi only I am going to go use here. So we can see where the point lies here. On drawing the figure, we can observe like this. So the circle of radius pi by 2. So the point will be actually minus pi. Obviously the point lies outside the circle. So we can take the complete equation 0 if the point lies outside the circle like this. Third one, The given circle is like this. Mod z is equal to mod z minus 1 is equal to 1 is a circle with center at 1 comma 0, that is x is equal to 1, y is equal to 0 and radius 1. So the point 1 comma 0, it is nothing but the circle lies on the x-axis, positive x-axis, and radius 1. The point 0 comma minus 5, we have to find out where it is going to lie. So on drawing the figure, we'll get the equation like this. So 1 comma 0. So obviously the point pi is nothing but 3.16. So the value will be minus 3.16. So on observing the figure, the radius will be only 1 here. So obviously the point lies outside the circle. So if the point lies outside the circle, we can take the complete Cauchy's theorem is equal to 0. So now we'll see one more examples related to the Cauchy's integral formula. So evaluate integration over the region C, z square plus z plus 1 by z minus 2 whole cube dz over C mod z is equal to 3. So here we can observe that the denominator z minus a whole power n plus 1 form is there. So here we can observe that n is equal to 2 when compared with the actual formula, and the function will be z square plus z plus 1, we can take it, and the circle is here mod z is equal to 3. So it means that the center at the origin and radius is equal to 3. So now we'll see the steps one by one. So the point z is equal to 2 lies inside the circle mod z is equal to 3, like this. So since on comparing the equation we are having a is equal to 2 there, obviously the point will lies inside the circle. So therefore the directly we can take the formula like this: integration over the region C, f of z by z minus a whole power n dz 2 pi I n factorial f power n of a. So on comparing the actual equation, we have n is equal to 2 here. So on replacing n is equal to 2 and a is equal to 2 in the formula, we'll get the equation like this. So since the equation contain f double dash of a, so we have to find the f double dash of z from the equation. So in the sense, we have to differentiate f of z equation twice. So we'll get equation like this: f double dash of z is equal to 2, we got it. On replacing the point a is equal to 2, no change in the value, so we'll get f double dash of 2 only, 2 itself. Therefore we'll get the equation like this. So the integration over the region C, z square plus z plus 1 divided by z minus 2 whole cube dz will be equal to 2 pi I by 2 factorial f double dash of 2. So on simplification, we'll get the equation like 2 pi I. So the final solution is integration over the region C, z square plus z plus 1 divided by z minus 2 whole cube dz is equal to 2 pi. So in the next lecture, I'm going to discuss about bilinear transformation and few examples related to the bilinear transformation. Thank you.